In this Chemistry Goes to the Movies video, I'm going to be looking into the chemistry behind Marvel's 2015 superhero film Ant-Man. In the film, the hero Scott Lang is able to shrink down to the size of an ant using a supersuit. We're going to be focusing on whether this is actually possible. In the movie, Dr. Hank Pym's, played by Michael Douglas, has created Pym particles, which he claims are able to decrease the space between atoms. Now there are three key points to look into for the chemistry behind Ant-Man. First, we're going to ask, is it possible to decrease the space between atoms to shrink to the size of an ant? Then, what happens when you increase the space between the atoms, like in the movie when an ant is enlarged to the size of a dog? And finally, what are the weight implications of changing an object's normal size? So to answer this question, you must first appreciate the forces acted upon atoms from both covalent bonds and intermolecular forces. At this point, you may argue that atoms are 99.999% empty space, and so decreasing the space between atoms will not have a profound effect. But at the quantum level, this idea will break down due to something known as Pauli's principle, found in the Lennard-Jones potential equation. The graph on the right illustrates the Lennard-Jones potential, which shows that as the distance between two atoms decrease, the amount of repulsion which must be overcome to move the atoms closer increases, which basically means that a lot of energy is needed to move the atoms closer together. So looking back at the question, what happens when you shrink a man down to the size of an ant, Scott would have to overcome the repulsions between every single atom in his body to shrink, which would require a huge amount of energy. If this was ever achieved in real life and an object was shrunk so it was many times smaller than what it's supposed to be, and the energy was no longer being added to the system, the atoms would repel with such force that an object would probably explode. One alternative way of shrinking a person would be to decrease the actual size of atoms by decreasing their Bohr radius, although this would be extremely difficult to do as it would involve changing some fundamental parts of chemistry. If in the film the Pym particle was able to accomplish this, it would make the supersuit much more viable, as well as explain some scientific plot holes in the movie, making scenes like this possible. The next question refers to a scene towards the end of the movie when an ant and a child's toy are accidentally enlarged by hundreds of times their normal size. This would cause the exact opposite effect of the previous question. Referring back to the graph of the Lennard-Jones potential, it can be seen that as the distance between the atoms increases, the overall attraction between atoms decrease and bonds deteriorate as the electron clouds of each atom no longer overlap. In relation to the movie, this would mean that all of the covalent bonds between every atom in the ant's body would weaken and break as they are too far apart to effectively interact. In other words, as the ant and the toy grew, they would turn into a cloud of dust. The last question we're going to look at is what are the weight and density implications of changing the size of an object. When Scott shrinks, his volume changes but his weight remains the same. This means he becomes extremely dense. Assuming that Scott is the average weight of an American male, 87 kilograms, has a height of 70 inches and a volume of 0.0664 meters cubed, we can calculate that he would normally have a density of around 1,300 kilograms per meters cubed. In the movie, Scott shrinks to around half an inch, making him 140 times smaller than his normal size. This would give him a density of around 183,000 kilograms per meters cubed, making him over 33 times more dense than the Earth. Throughout most of the movie, examples can be seen where these facts are neglected, such as when he is able to fly around on an ant without crushing it, which is probably done to make the film more entertaining.